Derivative of inverse trigonometric functions. Derivative of sine inverse x, where -1 is less than x is less than 1. Now proof. Step 1. Let y equals to sine inverse x, where -1 is less than x is less than 1, or x equals to sine y, where minus pi upon 2 is less than y is less than pi upon 2, equation 1. Step 2. Y changes to y plus delta y when x changes to x plus delta x. So x plus delta x equals to sine y plus delta y, equation 2. Step 3. Subtracting 1 from 2, we have delta x equals to sine y plus delta y minus sine y equals to 2 cos y plus delta y upon 2 into sine y upon 2, or 1 upon delta x equals to 1 upon 2 cos y plus delta y into sine delta y upon 2, equation 3. Now step 4. Multiplying both sides by delta y. So delta y upon delta x equals to delta y upon 2 cos y delta y upon 2 sine delta y upon 2 equals to 1 upon cos y plus delta y upon 2, 1 upon sine delta y upon 2 upon delta y upon 2. Step 5. Proceeding the limits when delta x tends to 0 and consequently delta y tends to 0, we have delta y upon delta x equals to limit delta x tends to 0, delta y upon delta x equals to 1 upon cos y plus 0 into 1 upon 1 equals to 1 upon cos y, equation 4. Now cos square y plus sine square y equals to 1. So cos square y equals to 1 minus sine square y equals to 1 minus x square using the equation 1. So cos y equals to plus minus square root of 1 minus x square. But since y belongs to minus pi upon 2 and pi upon 2, so cos y is a non-negative. So from 5, cos of y equals to plus minus square root of 1 minus x square. Hence from 4, dy upon dx equals to 1 upon square root of 1 minus x square. Hence d over dx equals d over dx of sine inverse x equals to 1 upon square root of 1 minus x square.